There is something you need to know before you deploy your smart contract onto a public blockchain, a public network. Now, Ethereum actually refers to a protocol. It's actually a protocol. This means that there can be multiple independent networks conforming to this protocol that do not interact with each other. So when you hear the word network, I want you to look at this. It says networks are different Ethereum environments you can access for development, testing, or production use cases. Your Ethereum account will work across the different networks, but your account balance and transaction histories won't carry over from the main Ethereum network. So for testing purposes, it's useful to know which networks are available and how to get test nets so you can play around with it. Now, when people say that they're transacting on Ethereum, they're probably most likely referring to the mainnet. This is the primary public Ethereum production blockchain. So if somebody just call you and say, hey, I just bought an NFT off Ethereum blockchain, they're referring to mainnet. Okay, this is the main network. This is where people exchange value, make a transaction, deploy a smart contract. Anything that happens in the real world, this is most likely what they're referring to, the mainnet. But this is not the only network that uses Ethereum. There are also networks independent from mainnet. So remember this part here, it says that they're independent from mainnet, but your account will work for different environments, even though your balance and transaction history will not matter, right? So this is really good for testing. So testnets, this is the isolated environment that the article is referring to. In addition to mainnet, there are public testnets. These are networks used by protocol developers, smart contract developers to test and make sure that the contract works well, make sure that everything is good, that it's working as intended before they deploy that, before they make this deployment onto the mainnet. If you're familiar with this paradigm, you can think of it as an analog to production versus staging servers. So it's generally important to test any contract code you write on a testnet before deploying to the mainnet. So let's take a look at how this looks like in our Brownie setup, and let's also try to run a few commands to get ourselves familiar with how do we switch between the different networks. So it's really important that we test our contract code on the testnet before we deploy that onto the mainnet. Sounds intriguing? Well, make sure you hit the subscribe button, and when you're ready, open up your IDE and let's dive in. So this is where we left off last time. I hope that you've written some tests as well. Give it a try if you haven't. And I want to make sure that you are in the right directory, so we have the test folder in here. And what we're gonna first do is to create something called the brownie-config file. Now the brownie-config file works with a YAML format, YAML. So you can go ahead and just say touch, and you can say brownie-config.yaml. If you want to, you could also just right click and say new file and then just give it a name, but the name has to be brownie-config.yaml. Then you say enter. So that's how you created a blank brownie config file. So what exactly is this configuration file? This is how you modify Brownie's default behavior. This is a configuration file. For the most part, it's optional, which is why we haven't actually done that until this part of the video. But the configuration file itself, it has to be brownie-config.yaml. This is how Brownie knows that, okay, that's the config file I should be looking for, right? And if you save this file in the root directory of your project, it will be loaded whenever the project is active. So every time you run a project, it's gonna know to look for the configuration options here and do what you tell it to. If you want to, you could also save this brownie-config.yaml file in your home path. So this would be somewhere like this. And I'm not gonna do that, but I could show you, for example, this is my home directory. And in my home directory, just clear the screen out. And if this file is in your home directory, it will always be loaded no matter what project you're working on, no matter what directory you'll be in, as long as you have brownie-config.yaml in your home path. So if you have a very similar configuration for all of your smart contract projects, you can just have that in your home path, and that will probably save you some time as well in the future. Now, all configuration files here in this file, they're optional, but I'll maybe talk a little bit about some of the more common ones. The first one I want to talk about is something called the networks. So this is what I alluded to earlier in the intro, and this is how you set up your network management within Brownie. Brownie can be used with both development and live environments. A development environment is what we've been doing so far. It's a local temporary network used for testing and debugging. For Brownie, it uses Ganache for development environments, and that's what we have been doing in the last few episodes of the series. And a live network is a non-local, it's a persistent blockchain. Anything you do in there, it's gonna be there, it's gonna be on the blockchain. You can come back to your code tomorrow, and if you run it, it's still gonna be on that same persistent, stateful blockchain. So this term, when we say a live environment, this term is used to refer to both the Ethereum mainnet and for all of the testnets that we talk about. So it could be Coven, it could be Rinkeby, it could be any of this. And that's what we mean when we use the word live environment. So how do you do network configuration? When you have development, you could just put development. So for example, I could have some sort of configuration for Rinkeby specifically. So we don't want that to be capital, Rinkeby. And you have some sort of configuration here. There is an option to verify your code when you publish this to a live net. So there is a service called etherscan, and it performs this thing called the source code verification. Source code verification allows anyone to just verify that the deployed contract is using the source code that you said you're using. So you can have your source code here, and you can have your deployed contract, and you're publishing your source code. And if they're the same, meaning this is the written code that generate this deployed contract, then anyone can just take a look at on etherscan and be able to verify that and say, okay, that is in fact the code that is used to construct this smart contract. And that has a lot of benefits. For example, it builds trust as well, and it allows anyone to sort of audit it to make sure that the contract is doing what you said it's doing. And this is the automatic source code verification. We're gonna see an example of that later, but right now I'm just gonna say that every time I deploy to Rinkeby, I want that verification to be turned on. So I'm gonna say verify, and I can have it as true, for example. You can do that for another testnet. You can just set it up even before you do that. So you can say common, and you can do the same thing. But just to illustrate the idea, I don't really want to have to go through all of these different testnets. So you're just gonna have that. We can also say development. Within development itself, we're gonna say the default for that is, the default for that is gonna be false. So we're gonna say if we're just running our code on the local blockchain, we're just trying to do this in development mode, then you don't have to worry about trying to verify that, because there's no point in doing that, right? And what we can also do is we can just set a default here. So you can say default would be development. And this is how we set up the default network. So every time we try and deploy our smart contract, Brownie is going to look at this configuration file and say, okay, if you specify any parameter, I'm going to use that. But if you did not specify anything, I'm just going to use the default. In this case, it's going to be development. Okay. So if you want to learn more about networks, what you can do is to hop into Brownie and say Brownie networks list, and give it a while. Then pull up a terminal a little bit, and here it says the following networks are declared. If you try and run this on your local machine, you probably see a little bit of a some different setup here, but for the most part, it's going to be largely the same. So development, it says Ganache CLI, that's referring to development. So this is the name of development. So we say the default will be this, the Ganache CLI. If you want this to be a different one, you want to change that. Okay, so let me summarize this really quickly. Networks, when we talk about networks, they broadly categorize as development, which is local ephemeral environments. You create a blockchain, deploy a blockchain, deploy some smart contract onto the blockchain, and then when you're done with your testing, done with your development, you shut it down. It's not gonna persist. It doesn't exist anymore. Okay, and then there's the live, the non-local, persistent environments for smart contracts. And live networks are additionally categorized by chains, which is in here. So you see the Ethereum, within Ethereum, you see mainnet, Robston, Rinkeby, Gorley, I don't know if I pronounce Gorley, Coven, and there's also the other kinds of chains here. So when you set this up to be default development, every time you try to spin up Brownie, it's gonna run development, but you can use the network, the -- network flag to sort of change that. You can say network and you can say Rinkeby, and we'll see how to do that in a while. So let me bring this down a little bit more. Let's talk about the configuration file. So within the networks itself, there's the default development. Within development itself, there is also, you can also further configure it. You can say, let's maybe do it here, right? So apart from just verifying, you can also set up like, I want to have some sort of gas limit. So every time you make a transaction, you initiate a transaction, there should be some sort of gas. Somebody have to pay some gas in order to alter, to modify the state of the blockchain. You can say max, and max is kind of the default for development anyway. So even if you did not specify this, that's going to be the default value. So the default, this is the default gas limit for any kind of transactions, for all kind of transactions. So if you set this to auto, then the gas limit is going to be determined using some sort of algorithm. This is under the web3.edh.estimate gas. So there is an API that try to estimate, the right gas limit, and it proposed that to you, and that's going to be the recommend. You can have gas price, you can have max fee, you can have all of this, and I think that as we progress throughout this series, you probably can see more of them. But we're just gonna keep things simple. This is kind of what we need now. Sometimes you want to put in your private key, and you'll be tempted to put it in here. You're probably thinking about something like, maybe I can create a keys parameter and I can put my, let's say, my private key in here, private key, and this is where you put your private key. So this is actually a bad idea. You don't want to have your private key in here. You want to be really, really careful every time you write your private key anywhere, just generally working in a smart contract. So one thing you can do is that if you absolutely have to put it in here to simplify it for yourself, you want to make sure that this is actually git ignored. So you want to click onto this source control, you want to right click on this, and you want to say ignore this file, add to git ignore. Okay, you don't want this to be in a git repository. So again, click on this, right click, and then add to git ignore. So that would just go ahead and add this line to sort of git ignore that, so you don't commit that accidentally onto GitHub and everyone can see your private key. That is going to be disastrous, because anyone who has access to a private key can empty your wallet and do whatever they want with your wallet. So you don't want to have that happen to you. So maybe a better idea is to actually load in the environment variables, and the way you load in environment variables is through this thing called the .env, and you can say something like find the env file, and then here you can just say private key. So I'm gonna say env2, and I'm gonna just show you how I do it. So create a new file, say .env2, and then .env2, let me bring this to the left. This is a really important step. You want to make sure you do this correctly and not have any of this committed to the GitHub. So env2 should also be git ignored. So I'm gonna say private key, and this is where you actually write your actual private key. So if you want to store any kind of API key, any kind of your wallet private key, anything at all, anything that should be a private key, you don't want that to appear on version control, least of all if it's a public repository. What you should do, right click, make a new file, .env, and within here, .env, link that to .env. I have my .env, and I'm not going to show you what I have in there, but you need at least a private key later on when you want to deploy this to Ethereum, either the mainnet or one of the testnets. We're going to be doing the testnets, right? So you want to save that, save this file, and continue on, move on from there. So have one of this key, make sure that the name is private key, copy that and paste it in here. Add this to tell this file that this is a variable that you should be loading in from .env. Okay, I'm just close this out now. I'm gonna say don't save. If you know that you've done all of this correctly, if you see that almost any IDE, it will show you that, okay, if the file is it says it's unstaged. So unstaged means that it's actually, Git actually is aware of the file. It's saying that you haven't staged the changes you make in the file. So that's not a good thing. What you want to do is you want to right click as well, and you want to just git ignore that. So you see that brownie_config.yaml, I git ignore that, so it's actually grayed out and it doesn't show me an unstaged. Same thing for .env, it's doing the same thing. So take a minute to set up your brownie config to what I have here. Now every time you run brownie will look at this file, brownie-config YAML, and it would then hit this .env, and then what brownie would do is that it's gonna load the .env file, resolving the file relative to the project root. So this is relative to the project root because they're in the same folder. I can just do it like that. But if you move brownie-config into your home folder, you want to make sure that this is also reflected. The changes is also reflected in brownie-config. The file would have to be relative to the project root itself. I like to maybe move this up a little bit, arrange it like this. It's maybe all personal preference. I like to move the .env file up, keys there. Then next thing that is quite common as well is dependencies. So dependencies would look, oops. Dependencies is kind of a list of all of the dependencies that is in your smart contract. So for example, if we're building a smart contract that is intended to perform some sort of trade on the Aave platform, to maybe do some flash loan, borrow some tokens, maybe add a collateral, we're interfacing with the Aave protocol. So in that case, that will become a dependency. We haven't really actually seen this in action, but just to show you how it looks like, you're gonna have something like AAVE, Aave, and then you have protocol, and then this is the path to that protocol. And so this could look something like this. It could be 1.0.1, and that is saying that, okay, that is going to be a dependency. So Brownie knows that this dependency is needed. It will pull that dependency before try to build out your contract, so that any references to this dependency, in this case Aave, can be resolved. So if you have multiple dependencies, you just have to keep on putting up the list here. So for example, we have another DeFi, and we can have something else, some protocol, and then we can have some other thing, maybe the Web3, some other protocol, or let's say Chainlink, some other protocol, right? And protocol 1.1.4, right? So that's how you build up your dependencies. Obviously, I'm just putting in some dummy ones here. And remember how we use Brownie to run coverage and to run reports and stuff? So turns out we can also control the behavior of that. So there is the reports key that allows you to change the settings related to reports that govern the behavior of coverage and guest profiles. We've seen all of this before in the earlier videos in this series. So what we can do is somewhere like here, create a reports key. Then you can specify to maybe exclude certain contracts. You can say something like exclude, and you can say exclude. You can even have exclude path. So just to say like, okay, this path, you should exclude this path. And let's say we put all of this in the contracts folder. So we can have contracts. We can have, let's say we don't want any mocks to be tested. So you can say this, and you can just say ignore everything in there, right? Or you can just have contracts, contract.sol. You can also say exclude path. You can also just exclude specific contracts, so you can do the same thing like what we see up here, but you can name the contract and you can have like testing contract. Or in our case, like coin, in our case. Compiler is another key that you can use to set configuration for your Solidity compiler. So we can have something up here, maybe between the dependencies and .f, we can have something that says compiler solc remappings. We don't actually want a dash here. And solc stands for Solidity compiler. So here you can set up a version. You can say use a specific version of that. You can do that. You can version. You can do that. You can also have a specific settings for the optimizer, and so on and so forth. If you want to turn on wiper, you can also do that. You can say, well, I want to write in wiper. You can have wiper compiler. You can specify the version for wiper. So we're just gonna stick to Solidity. We're not gonna have to worry about that. We're also not gonna have to worry about most of all of this. Just remove all of that. And if you want to, you could also change the EVM version like this. And through this, you can set the EVM version to compile for. If you set null, then the most recent one is going to be used. Okay, so you can use an older version of EVM if you want to. For example, Petersburg, Istanbul, you can put values in here. But if you use null, then and that's the default value. Null is the default value. And if you use null, then the most recent one is going to be used. Okay, but really personally, I use remappings a lot more than the other settings in here. So remappings is kind of a way to say that, hey, every time I refer to in my smart contract, if I want to refer to this Aave protocol, I may not want to just type the whole thing out here. Instead, just do a remapping. So I can do something like Aave, and every time you see Aave, I'm actually referring to this path. So you just copy that and paste it in here. This is kind of a remap. In your Solidity code, if you find Aave, then take that, replace that with this. So this is kind of just a remap. You can also have this remap to somewhere like Zeppelin, and now remap to somewhere on your own computer. You can have maybe user local library. For mine, it's somewhere like maybe under Open Zeppelin, and then I have a contract here called contracts, and some other contracts or something in here. So every time it sees the Zeppelin, when I'm trying to import or I'm trying to reference this, it knows to look for this path instead. So you can do that as well. And what we really need, most of these are just for demo purposes, so I'm gonna have to remove most of this because I really don't need this. I'm gonna keep .env, I'm gonna keep the keys, I'm gonna keep the networks, but I don't need to change the way the reporting is done. And finally, every time you run Brownie console, you go into the console and you can see something like, when I do something like import, you see that it tries to autocomplete for me, right? It gave me some suggestions here. So that is also a behavior I can change within this configuration file. I can say console, and within console, I can change how I wanna, this is the colors. I can change the color of that as well if I want to. I can say change the colors. I can say set colors to be true. I can have the color style to be something different. This is also acceptable. The default, I believe, is called monokai, like this, but you can change the value to something else. And then there is the auto suggest, which is what it's doing right now. So if I do something like import, it tries to give me suggestions there. So auto suggest, the default is also true. There is also the completions, and that is also true. So If you don't want any of this, you can change the console. I'm pretty happy with how the default values are for the console, so I'm not going to change any of this. I'm just going to remove all that. But this is kind of how a brownie-config file will look like, and you can change it. I'll point you to the documentation. You can read more about that. We're not going to have to worry too much about any of that. So just going to quit out brownie console, and I'm going to quickly save this file because this is kind of what I need right now. And once you're happy with your brownie-config file, I want you to bring your attention back to the browser. So open up a browser and go to metamask.io. And this is a crypto wallet. You can use anything, but for me, this seems simple enough. So I'm just gonna stick to MetaMask. You can go ahead and download that if you want to. You could create an account. I've already done the process here, so I'm gonna skip all of this. But you could just go ahead and say download MetaMask, and it will ask you what browser you want to download it on. And you have Chrome, you have iOS, you have Android. So you can just say install MetaMask for Chrome, and these are the supported browsers. Just pick one of them, and you should see an extension like that. Give it a second. Once you're done downloading, you may have to create an account. So go ahead and do that as well. And the setup process will probably take you 5 minutes. It will give you a secret phrase, a recovery phrase. That's when you lost your password, you forgot about a password. So you want to make sure that it's completely out of your version control, okay? That shouldn't be anywhere. No one should see it apart from yourself. Once you have that, once you have an account, should take about 4 or 5 minutes. But once you have an account, proceed to log in. And I'm going to do that right now. Once you sign in, you see your account, and this is your account. You can have multiple accounts. You can go ahead and create new accounts by clicking on this, and then say create account. You can also connect to a hardware wallet if you want to. I'm not going to worry about import account right now, but once you have an account, there are all these different networks, and just like what I said earlier at the beginning of the video, is that you will have one account and it will work across all the different networks, but each of them will have a different balance. So for example, here I have 0.41 ETH. But if I click on this as a test network, let me go into another test network called Rinkeby, and I see that in Rinkeby, I have 1.5 ETH. So the actual one, this is the Ethereum mainnet. And this is what you will use to transact, for example, buying an NFT off a marketplace, or maybe joining an auction, any of that sort. So Ethereum mainnet is the real Ethereum network that everyone performs the transactions on. But the test networks are really good for developers like yourself trying to write smart contract and test it and make sure that your code works before you deploy that onto the main network, right? So let's go into Rinkeby, for example, and you can see your activities. You can look at all the different assets you have in here. So all the assets that you have, it's going to be listed like that. We're going to probably learn more of this in a later part of the series. But for now, I want you to just click onto this one and then say account details. This is going to be a public key. But what you want to do is to export your private key. So you don't want to have anyone see this private key. You're gonna click on export. Just for export security, it's gonna ask you to type your MetaMask password again. So you want to put in your password here, and it even has a warning here that says never disclose this key. Anyone with your private key can steal any assets held in your account. So including your NFTs, including your everything that is associated with your account. Okay, so let me put in my password, and I'm gonna say confirm, and this is your private key. Then you click to copy. You bring it back to Visual Studio Code, and then that's when you put into your .env2 file. So in your env2, this is my private key. So you paste all of that in. Then you save it. So now when your .env refers to your .env, and then within the .env file itself, because you specify that key, it's gonna take that key and it's gonna load it into keys, the keys key. And you can think of it like a dictionary. So the key value, so this is the key, this is the value, right? Private key, where is this from? This is from your .env file, your .env file. So go ahead and get that set up, because now we're ready to deploy our valid contract onto one of the test nets. Well, to deploy a smart contract onto one of these live networks, it could be one of the test nets, it could be the main net, you will need to pay some gas fee. And the gas fee is gonna be in Ethereum's native currency called ETH. Okay, so we talked about that a little bit in the earlier videos. But now let's go and try and get some fake ETH onto our wallet so that we can use the fake ETH to actually perform this deployment. The terminology that you want to search for is called the faucet. So for example, I'm going to use Rinkeby. So you can search for Rinkeby faucet. And what is a faucet? A faucet is a developer tool to get testnet ETH in order to test and troubleshoot your decentralized application. So a faucet gives you testnet ETH. So these are fake ETH. These are not ETH that could be transported onto the mainnet, which means they have no value apart from you being able to test and troubleshoot your code. Alright, so there are a few here that says Rinkeby, Ether, Faucet. You can pick one of them. There is this one as well. So if you click onto it, it asks you to put in your Ethereum address and you say give me Ether, and you can ask for 3 Ethers or 7.5 Ethers or 18.75 Ethers. So in the faucet.rinkeby.io, it needs a social network URL. So one way you can do that is through Twitter. So I'm going to go to Twitter and I'm going to click on my account. I'm going to copy mine and I'm going to say requesting for some if faucet if. So the text really doesn't matter. If you want to, you could also just click on this one and say make a tweet with that, and it would just write that for you. It really doesn't matter. But what you want to do, the text around it doesn't matter. What you really want to do is to just change what is in here. So replace that with your own address. You say requesting faucet funds in this on a Rinkeby. None of this really matters. Okay, so all of this really you could just delete all of that if you want to. You can also keep them if you want to, and then you just tweet. And once you've done tweeting, it says your tweet was sent. You click onto that, copy that, get back here, paste this, and you pick whether you want this to be 3 if, 7.5, 18.75. Now what is the difference between them? Now if you pick the 3 if, you can do this and then you're gonna go into an 8 hours cooldown, which means the next time you get a request, that would be 8 hours from now. And you can also say, well, what if I just take 7.5? So if you do something like 18.75, you're gonna have to wait for 3 days of cooldown. So you're gonna have to choose wisely what is it that you want here. So let me pick the 18.75 and you say give me if. You can also look at the faucets.chain.link. You can also click on that one, just search for it. This one will probably ask you to connect to your wallet, so you want to do that, connect, sign in, and it will automatically detect your wallet address. So it fill that up for you, and you can say, oh, I don't need the link, I just need to test if. Because when I'm deploying my smart contract onto the testnet, if is really what matters. Link is when you want to use some of the chain links contracts and you need to pay in link. For now, we're not gonna do that, so I can just keep this on. You wanna confirm that you're a human, so I'm gonna pick this and then send request. It's gonna say waiting for confirmation, but you send a transaction here and you can click on that transaction to sort of track that. It says that this is a Rinkeby testnet transaction only, but it's giving you a transaction hash. It's not included in any of this block yet, so it's still waiting, but it's transacting to your wallet. This is the same wallet that you see in here. So 3C7, 3C7. And how much is that? Value 0.1 Ether. So it's going to give you 0.1 Ether. And it's also going to cost some gas price, but that's going to be bought by the message.sender, so not us, right? So let's just wait for a little bit here. And request complete. Congratulations, 0.1 testnet ETH has been sent to your account. This is transaction hash, and this is the address. To confirm that, we can open link in new tab, and it says success, and this is the block, so you can look at what are all the other transactions within the same block. Timestamp 42 seconds ago. This is again our same address. This is how much you have to pay for this transaction to happen. Every transaction on the blockchain costs some gas, and this is the price of that gas. Okay, so that's the Ether, and 10 to the power of 18 of that will be Wei, and Gui is 10 to the power of 9. And you can hop back up, inspect the state of that. You can see before, this is how much there is, and then after, that is how much there is. And this is 1.507, this is 1.607. You can also click on your wallet and see that, hey, this is exactly what I see here. And you can click on the activity to make sure that you receive the 0.1 ETH. Alright, so now that we have some ETH, we're ready to close the tab and get back to Visual Studio Code and perform our deployment. How exciting is that? The simplest way to deploy your smart contract is through a deployment script. In your directory, look for scripts folder. Within scripts folder, you should see that there is already a deploy.py. That's from one of our earlier exercises. If you click onto it, you have the simple storage, you have the coin, so all of this doesn't make sense anymore. You can go ahead and delete them if you want. I'm just going to keep it here for now, but I'm going to go ahead and create a new file, and I'm going to call it deploy testnet. So this is where we will write our code to deploy this onto a testnet. For the purpose of this tutorial, I'm going to stick to Rinkeby just to keep it a little bit more focused, but feel free to use any testnet that you want. So writing a deployment script is very similar to what we've done before, and we have our imports. So let's take a look at this. We have the import from brownie import simple storage coin account. So we obviously don't want the other contracts, we only want our ballot contract, and then we would have our main function, and it would just run taking accounts, deploying, and that's it. So there should be maybe 4 or 5 lines of code, right? So let's go ahead and say from brownie, and just to have some sort of reference, let's open up our test coin and put it next. Side by side, we turn off the sidebar just like this, and we can say from brownie import coin accounts. So we know that these two are what we, or at the very minimum, this is what we require. We actually want ballot, so we're gonna have ballot. So maybe this one we should also change this to test and test ballot instead. So we don't need the first one, just test ballot. That looks about right to me. So we go ahead. There are proposals that we created here, but just to differentiate it a little bit, I'm gonna have proposals. I'm gonna have maybe 4 proposals to put it on the actual testnet itself. So we're gonna have 1030, 1031, 1032, 1033. And similarly, because we know that in the ballot contract, if you open up ballot.sol, we see that this is gonna be bytes 32 array. So bytes 32 array means we probably want to do the conversion as well. Like I said, actually brownie takes care of a lot of that for you anyway, so you don't really need to do that. But let's just maybe just keep it to in my view, it's probably best practice to be more explicit. Just gonna copy that, paste this in here, call it byte proposer. Now it's complaining that convert is not found. Okay, so what do? We bring it in. So we have the proposers. It's a list of 4. We just have to run in a for loop, just list comprehension. Okay, what else do we have? We need to deploy. When we deploy, it's gonna look like this, and it's gonna need an account, right? And all this time we've been using account 0 because that's what Ganache provided to us. But for this actual deployment, we will need a real account. We will need at least the secret key to this account, so that Brownie knows which wallet should be in charge of the deployment of this and be the one that is paying the gas fee and be the, in this case, the chairperson. So let's go ahead and say account. Now this is where I would like to open up my config file. So we have a config file, we have our development, our Rinkeby, this is our keys. So what do? I set accounts. Now this is not gonna be correct anymore, right? Because these are all dummy accounts anyway. Now it's the real thing, that's the real deal. So what do? We say add, and then we say bring the key from this config file. So how do we do that exactly? So you can go up to brownie and you can say import config, and that would just import this file. And then what do? You say from here, take the config file and then find keys and then find private key. So let's do that. Right, what we need now is a main function. So let's do that. Main. Let's quickly do a save here, get back into the test. What do we have? We have the ballot.deploy. We have to deploy with something. And what is that something? Let's open up the Solidity file again. So let's say ballot. And it says that when you run the constructor, you call it with a bytes 32 array of proposer names, right? So let's do that. So we call ballot.deploy. The first thing is just the list of proposers, which is here. So byte proposer, byte proposers. And then what's next? The from account. So let's put from accounts. We're not gonna do account 0, we're gonna do this one. So this is saying that, okay, that's our key. Take that key, deploy from that key. Very, very similar to what you've written in your test. So if you run your test correctly, if you written your test correctly, you should have an easy time just writing this deploy script. And this is kind of it actually. But let's just do one more thing. Let's also use the verification feature that we have here. So we can go ahead and say, do we want to publish our source when we deploy this contract? Do we want the source code to also be published and to be verified? We say, yeah, we probably want that. So let's go ahead and say publish source. This should be a true or false. So you can have true, you can have false. But what do we learn? We learned that it's probably better off to control all of this within the configuration file itself. So you don't want to hardcode this. Instead, you want to do very similar to what you've done here, above here. So you want to say config. And what do you have here? You have networks, Rinkeby, verify. So let's do networks, which gets into this Rinkeby, which Rinkeby, and we want this key, verify. So really you could have just saved yourself some typing, just put true, because it's referring to true anyway, but we want to just be able to just look at this configuration file and figure out what our main configuration without looking at all the different scripts. So this is kind of a way to just parameterize things here, and then we said, okay, if we need to get the value, we just have to reference this file, which is the configuration file, and we do that from using brownie import config. And in the future, if you want to change any values, we don't have to look for all these different places. We just have to get back to the configuration file and change things directly in this one file. So that's probably better practice. And if you want to just print a successful message, you can say success. So this could be a transaction. You can call it a deploy transaction. This is your deployment transaction, and you can then put a print message. I could have a f string, and I say successfully deployed. And you can take this and you can pass this in here, put with an address. So in this case, this is a ballot, so let's just call it ballot, and I'm going to copy this, paste this in here, say address. So successfully deployed ballot contract at this, or rather 2. Save it. Now that we have this file, Brownie knows how to run this file. So all we need to do is to run a script, and we do that by going to the terminal and we say brownie run. We give the name of this file. So this is deploy_testnet. We can just do deploy_testnet. You can use the .py. You can also even put the scripts and put a path like this if you want to. But if you don't, if you just put the name of the file, it's gonna know how to look into the scripts folder and find the right file anyway. So brownie run deploy testnet, this is gonna assume that you have a file called deploy_testnet.py located in the scripts directory. Then you put -- network. That's how you control it and say, oh, I want to actually deploy this into the Rinkeby network, and it's going to find the Rinkeby network and it's going to do the rest. So I'm going to execute this now, give it about 1 or 2 minutes, and I see that there's a key error saying that this is not found, right? It's saying that there is no such a key called key, and that's because we name it keys. So we just have to go back up there, save that again, hit up, run it again. Now it's saying that it's running scripts, deploy testnet main. It sends the transaction. Now this transaction is going to cost you some gas fee, and that is why you need to use the faucet earlier to get some test Ethereum so that you can pay the gas price that is required in this transaction. And what does it say? It says ballot deployed at this address, and it's waiting for API Rinkeby etherscan/API to process contract. And now it's saying that waiting for this to process contract, verification submitted successfully, waiting for result, verification pending. And this is when I realized that, okay, there is one problem here, is that I haven't actually taught you how to verify this properly, right? So by now you should be able to deploy the contract. You just have to turn this into false if you're following the tutorial. And I'm just gonna explain why that is, okay? So in order to use the verification feature, you actually need another API key. And the way you do that is you open up your env file, and there it is, your private key. This is obviously not a real private key, but you get the idea. You have your private key there. Then you want to actually have etherscan token, and you want to have some sort of etherscan token as well in order to use the verification feature. And if you actually have both of this, then it's gonna perform the verification and it's gonna be successful. In this case, I've already verified that while doing the demo, so I don't actually see anything else. But for you, you should be able to see that once you've done that, it would say verified in green fonts. And it's going to tell you that the successfully deployed ballot contract exists here. So how do you get etherscan, and how do we make use of this information right here? So let's start from the etherscan problem, okay? If you don't care about that, you just have to turn all of this into a false, or you can just turn this into a false. And in that case, it wouldn't bug you about an API key and say it was unsuccessful. So you can just turn this to false, and then the rest of this is the same. Nothing here should change. Just turn this to false and then try to run deployment. So if you're getting any issues, let me know in the comments. But if you actually want the verification, then you need to have this as true, and then you need a second step, which is to go into your env file and add another one called etherscan token and paste in your token. How do you get a token? Let me show you. So first step, go to etherscan.io and click on sign in. So there are a bunch of things in here. There's a lot of resources. There's the developers API. This is what you're going to be using. This is what you're going to be looking at. But for now, just click on sign in, and then it would ask you, do you have an account? If you don't have one, click to sign up. So go ahead, proceed, and complete the setup process, the account setup process. I already have one, so I'm just going to log into my usual account. And once you're in your account, look under the other section, there is this API keys. You want to click on that, and from here, click on the add button and give it a name, and then say create new API key. Alright, so you can name it anything you want. You can call this your ballot contract. You can say Samuel tutorials, and you can say create new API key. Once you've got your API key token, make sure that it's also stored privately to you only and not somewhere on version control, especially not on a repository that is public. So copy the token that you just created. I'm gonna turn this off now, go back to Visual Studio Code, and then gonna paste that right in here. So you wouldn't have dash, right? So that's your etherscan token, that's your private key. Your private key is your MetaMask wallet, that's the account. Click on the show private key, copy that, paste it in here. Etherscan token is what you just did, paste it in here as well. Save both of them. Then I'm gonna not save that because that's obviously just a demo. I don't even actually want this, so I'm gonna delete that right now. So going back to deploy testnet, now you can actually have this as true. So you can now toggle this from false to true again, and then rerun the same command, which is brownie run deploy testnet network Rinkeby. Now this is obviously going to cost you some gas as well, so you don't want to keep doing this, and it's also every time you run this, it's going to cost a bit of time. So look for the messages up here and pay attention to the transaction. This is a transaction that you initiated from your account, which is here, onto the Rinkeby chain, and it's saying that it's going to cost you some gas price, but the ballot is deployed on this address. So we can take a look at the first one, the transaction send. So copy that, and what do? We open up our browser again, and then we go edit etherscan.io, and within this, you don't actually need to be signed in, you can be signed out as well, that's fine. Paste that, search for it, and you see that there's nothing in here. And the reason why there's nothing in here is because this is actually on the main net. So what you want is you want to have etherscan, but on the code on the Rinkeby net. So rinkeby.etherscan.io. Now you paste this in and you search for your transaction. So you see it's successful. This is the transaction hash, and it gives you a status saying that this is included in that block. So if you take a look at the block, so this is where all the transactions, 56 of them, are grouped in this one block. So that is why you have the name blockchain. This is the gas use, and there's some other information you can find out from here, but we're not interested in that. We're going to just go back to this one. So rinkeby.etherscan.io/tx. TX stands for transaction, and within it there is this hash here, which is basically just this. Or you can just go to etherscan within Rinkeby, search for it, paste it in here, click on search, and it says this is a Rinkeby testnet transaction only, 9 minutes ago by us. Okay, from what? This is our wallet, and this is the same as our Rinkeby wallet right here. So you can see that, okay, this is the 3C7. So it's saying that we are the deployer, we deployed this contract, and this is the from, this is a to. So in a transaction, there's a from, there's a to. To what? To create this contract. This is a contract creation transaction. So it gave you the address of that contract. So this is where it can be found on the blockchain. And this is also the same as ballot deployed here. In fact, we can also see our print message here, successfully deployed. That's also in here, successfully deployed. And we can see this is exactly the same as the one here. And it's also exactly the same here, transaction send and ballot deployed 36B8A. And this is also the same as the one in here. This is the successful message that we wrote. So successfully deployed ballot contract to, and then what do we have? We said ballot.address, right? So this is the same as this. And you can compare that back to this. Alright, so now let's click into the contract. And now it's no longer a transaction, but it's an address. So now it should bring us to the contract. This is the same as what we just see in our Visual Studio Code. And we have the contract. We have the contract in here. And because I've deployed it twice, it's gonna say, okay, well, I verified that already, so I'm gonna give you a tick. But I did not actually have to even verify that, because I found that there is a similar matching source code. So I've actually seen this before on the blockchain, and that is because I deployed this twice, once to do the demo and the other time to record this. And so it's saying that this is the same as this, so both are the same. Because I told Brownie to publish source, and that's true, the publish source equals the true thing that we've just spoken about. But in the deploy_testnet.py, you see that there's the publish source, and we say that's true. This is what it's going to be doing. It's going to be publishing the source code that creates the contract. So this is the ballot.sol. It's going to show you all of the Solidity code that creates that contract. We can also look at the settings. We can also look at the ABI. We haven't actually talked about that yet, but it's all in here. In fact, we can also look at the transactions that is associated with that. We can say that, well, what if we make another transaction? For example, going in there and giving rights to vote, for example. Well, that would also be another transaction. So as we put more transactions in here and we do that over the series, then you can track all the transactions happening within this transactions tab. And then there's the events. This is kind of what we spoke about in the last video. I'm saying that if there is an event that I'm emitting, they should also appear in here. So let's say if somebody voted, if we declare a winner, we want to emit a message, we want to emit something, that something is going to appear in this events tab. So let's go back to contracts right now and let's look at read contract. And a lot of what read contract is doing is kind of what we do when we use the gather function during writing our tests. So for example, I can just get the chairperson, and it's saying that, well, this is free. So you didn't even have to send a transaction to get this, because it's just a view function, right? So it says that this is the chairperson. If we compare that to our wallet, you can see this is the same account that I have in here. And what about proposals? Click on that, and let's take the first proposal. Let's take a look at that. Let's query that. So that's the first one, index is that, and it gives you these bytes, and that's great because that's exactly what we have within here. So if you take this and you convert that to bytes, you get exactly this. In fact, if you want to, you could just print that and you can confirm for yourself that that is exactly what you have. So I'm not going to do that because we've already done that in the writing test for this contract. Okay, so you can see, okay, well, this is 0046. What about if I put the second proposal, 47, cool. What about the third, 48, cool. Let's do the last one. And we can do as many as we want because it really doesn't cost us anything. This is a gather function, it's a view function. We don't really have to pay a transaction cost because we're not modifying anything, right? So what about voters? Voters ask for an address. So we need to give it an address. We just have to copy that, paste this in, and if it says what? It says if you pass in an address, it's going to return a tuple of 1, 2, 3, 4 values. It's going to return the address, the vote, the weight, the voter. So let's query for that. There we go. Delegate. We have not delegated to anyone, so that's a 0. Vote, we don't have any vote, but we do have a weight of 1, which means that when we run the constructor, so let's go back to this. This function is doing what it's supposed to be doing. So it's saying set the chairperson, but immediately give the chairperson a weight of 1 anyway. So we don't actually have to then proceed to give right to vote to our chairperson. That kind of it's not so efficient because you end up paying another transaction, paying some more gas fee. You don't want to do that, right? So here we're saying that when the chairperson is initialized, just give him a weight of 1. So we have that. Have we voted or not? No, false, right? And then we have winner name. The default is the first one because that's how we wrote in the contract due to our logic. And then there's a winning proposal. Right now there's nothing. All right. So we can also look at the code of this and try to confirm that instead of having to go back into Visual Studio Code just to cross-reference with what we're seeing in here. This is also simpler for the general public audience, because they don't have to worry about downloading a file and then opening it up in IDE. They can see all of that directly in here, and they can see, okay, that's what's happening. So this is the read contract. Now what about the write contract? Now the write contract is where we make transactions and we try to modify something in our smart contract. So we can go ahead and say give right to vote, and we can give it another address. But I don't have another address, so I can't really use this function meaningfully. So let me go ahead and create another new account real quick just to be able to pass this in. So I'm going to paste that right in here. So this is creating a transaction, and within the transaction itself, if you look at give right to vote, which is here, it says, well, you have to give me an address. And if you give me an address, what I'm going to do is I can make sure that first check that the sender is the chairperson. In this case, it would pass. Then it says that, okay, make sure that the person that is getting these rights to vote have not already voted. So that's also going to pass. This is also going to pass. And then finally, just going to add a weight of 1. All right, so let's do that. So go ahead, paste this in. If you see a button here and you say that, okay, you haven't really connected to Web3, you want to click on that button and you want to just click on your wallet. So I'm going to use MetaMask, and it says that this is a beta version feature. That's okay. And now I'm connected. So I can now, if you pay attention to this, you will see that in the activity itself, you will see that it's going to incur some gas here, right? So I'm going to write this. MetaMask is going to pop up and it's going to say that, okay, you're trying to call give right to vote on this domain. So rinkeby.etherscan, that's correct. And it's going to say, this is the right to vote. This is the estimated gas fee. If you were to pay this price, your transaction will go through in an estimated 30 seconds. There is also a max fee here. If you read the details, it says this lowers your maximum fee, but if network traffic increases, your transaction may be delayed or fail. All right. So this is the total gas that you're paying. So it gives you a suggestion anyway, and you can decide, oh no, I don't really want to pay this. I can click on edit and I can change the value to be higher, to be lower. You can say edit suggested. It says right now network is busy, so gas prices are high and estimates are less accurate. Okay, cool. I'm not going to change any of that. And then I'm going to proceed to say confirm. I want to make sure that this account is the account that is the deployer account, the chairperson account. So you want to have that as the second account. Okay, so that's the first account. I'm going to say confirm and successful. So it's going to say review your transaction. So I can click on that, open in the new tab, and now you can see the block, timestamp, all of this is pending. But at least I know that I've made this transaction, and I can now click on read contract again, and I can say check for the second address. So paste this in as well, and now I should expect that the weight would be 1 as well, because I just gave this person a weight of 1 by extending the rights to vote to this wallet. So I'm gonna click query. There you go. So hop back into the other transaction and you refresh the page a couple of times. You see that now it's successful. It says 40 seconds ago, it's included in the transaction, and this is the contract address. What this is saying is this is our account, right? This is the from address. So this is from our account, this is from our MetaMask wallet, and then do what? To the contract. And this is the contract address. This is exactly the same as what you see up here. This one, right? So 36B8 is the contract address. This is the creator. This is our address, creator address, and you compare that. They're exactly the same. This is the gas price that you paid. And now let's go back into contract, write contract. Let's go ahead and actually vote for a proposer. So I'm gonna actually vote for the proposer, the first proposer, or rather the last proposer. So there are 4 proposers. The last proposer, that would be the index of 3 because it starts from 0, 0, 1, 2, 3. So I'm gonna vote for the proposer at index number 3. So I'm gonna click write. And MetaMask is gonna pop up again. It's gonna say, okay, from which account? Now I can choose to use the first account to vote for proposal number 3, or I can choose the second account. But I don't have any test if on the second account yet. I have my if on the first account, so I'm gonna stick to the first one, and I'm gonna just say confirm. And it says successful, view your transaction. I can now go back to read contract, and if I look at the winning proposals, it should now be updated. But let me go ahead and say proposals 3 query. Now it has a vote count of 1. It went from 0 to 1. And if I refresh this page, under read contract, winning proposal, now it's 3. Winner name, this is correct. And that's how we just interacted with our contract on rinkeby.etherscan. And anyone, because this is on a testnet, anyone can go in here and try and play around with this contract. You can give them the address. You can ask a friend to sign up for a MetaMask wallet or any other wallet that you choose. Have some test if, and come in here and play around with your contract. And I know that this is just a testnet, but this is exactly how you do it on a real Ethereum blockchain anyway, right? So all of this is given to you because you verified your contract. So you have the code, your read contract, your write contract. But if you did not verify that, you won't have these features, but you can still continue to interact with your smart contract just through code, which is what you've been learning and what you're here for. So to keep the video short and compact, I'm going to leave it for now, but I want you to go ahead and play around with the other features that you see here. So in your smart contract, there is the write contract, there is the read contract, and connect to your Web3 wallet. Make sure you play around with delegate and give right to vote and vote. And then within read contract itself, continue to try and maybe do a few more votes and make sure that you're familiar with the entire process of deploying a smart contract and then interacting with it on Etherscan, and just trying to have some familiarity with what it's like to deploy a smart contract onto a testnet. I hope this has been fun. It certainly has been for me. Make sure you hit the subscribe button. Share this with somebody else who is on the Web3 learning journey, and I'll see you soon.